I'm Chris McGuire. As Julia said, I direct the ocean program for the Nature Conservancy in Massachusetts. I'm really looking forward to this last panel where we're really going to talk about some of the things that we're doing, that people are doing in the water right now that could be used to generate some of the biodiversity benefits. We're going to start off at the kind of high level and have our final of a great crowd of speakers from the Netherlands talk about some of the work that's happening there, and then we're going to jump right here to the US and talk with a series of experts about the work that they're doing that could set us up for net positive projects going forward. So time is short. We're going to try and stay on time to make plenty of time for your questions at the end. I will set a timer with an annoying beep that hopefully you guys will finish before it goes off. But without further ado, I'd like to introduce our first speaker, Sharon Tatman, who's an expert advisor and the research coordinator of apparently the entire North Sea for Deltares, a Dutch firm. So thank you very much, Sharon. I don't know which one of those works.
Okay. So, hi everybody. It's really nice to be here. It's slightly humbling after some of the comments I had, also in one of the last questions about looking over the other side of the ocean to the Netherlands and looking at how things are done over there. And actually, I have learned so much in the last 2 days. And to be honest, I really don't think we're doing as good a job as I thought we were before I came here. So that's my take-home message. We've got a lot of work still to do. Which one do I use? So my name is Sharon Tatman, and I work at Deltares. Just for those who don't know Deltares, which is probably most of you, we're an applied research institute in the Netherlands. We're doing a lot of work on offshore wind farms, but we do also an awful lot of other applied research projects, and we do specialist consultancy work for the Dutch government, other governments, industry. We work worldwide. And to keep things easy, when we talk about offshore wind, we do practically everything below the waterline. So I'll go into a little bit more detail, but first I want to just set the scene of what's going on in the North Sea. So you've already seen where the North Sea is. I was very happy to see the little animation or the little picture from Ruud de Bruin earlier on. So it's a relatively small sea, but it is managed and planned by 9 countries, which makes it very complicated. And it's the busiest sea, well, one of the busiest seas in the world, if not the busiest. There's a huge amount of activity going on, and we're just going to make it even busier with the rollout of these offshore wind farms. And here is a picture of the planned and operational wind farms at the moment. There's some figures missing. There should be some numbers there. Oh, there they are, bottom right. So at the moment, the targets for the North Sea for 2030 is 65 gigawatts. So that compares, just make the comparison with your 30 gigawatts, up to 150 gigawatts in 2050. But we also just heard it being said about Rhode Island, little old Netherlands, which is one of the smaller countries in Europe, is actually sort of steaming ahead in offshore wind development. So the target we have set for ourselves in 2050 is 70 gigawatts, and that's the 5,000 turbines that are about to be built. For 2030, it's 22 gigawatts, but the rumor is that that will probably increase. There's a high-level summit happening this coming Monday with the nation leaders of all the North Sea countries, where they are going to negotiate new targets probably. And the rumor is there might be another 9 gigawatts being added to the 22 gigawatts, but that's just a rumor, so you haven't got that from me. But what it means is it's incredibly busy. And this has a lot of repercussions for the use of the space. And I've also been noticing one of my other take-home messages for myself is that we speak very different languages, very different wording, but we're all talking about the same thing. So I think when you talk about MPIs, we're talking about nature inclusive design measures. Basically, we're trying to achieve the same thing. We're trying to enhance biodiversity, stimulate more nature. And but what it means in the North Sea, I think we're coming from a different direction. The North Sea has an awful lot of activity going on. We are doing studies at the moment where we can actually see that we are not going to be able to do everything that is being planned for the North Sea. I think the Dutch government also realizes this, but they are trying to find ways of making efficient use of space, which is this multi-use concept. But we also have an ecological space problem. The Dutch North Sea, or the North Sea, is not a very healthy ecosystem, and we're trying to bring that back to its original state and improve the ecosystem health. And we need measures for that as well. And when we are building these wind farms, we are putting infrastructure into the water, and we need to mitigate the impacts. And we're coming from a nature legislation drive to do this because the EU sets quite strict legislation that all of the countries, the member states, have to abide to. So we are not actually allowed to have any negative impacts. We're not talking about net positive, we're talking about trying to mitigate any impacts. And that's a little different from what's been going on, the discussions over the last 2 days. I think, to be honest, the government would be happy if we could actually just make these wind farms happen on top of all the other use. From an ecological point of view, I don't quite agree, but I think this is the fact of life that these wind farms are going to be developed. But there's lots of unknowns, and we do research together with lots of our fellow institutes. As you have heard, the deciding factor for the tender decisions in the recent tender were these ecological criteria. And we're currently looking at a new tender for this IJmuiden Fair, which you can see the two areas are encircled off the Dutch coast. And what is good is that there are a lot of criteria written into these tenders that the developers are going to be asked to help and develop and provide R&D for. What measures can we take to enhance biodiversity? So that's the good news. Okay. So this is just a very, very quick outline of the kinds of measures that we are applying to the North Sea. You've heard lots of them already, so I'll go through them very quickly. Mitigating the piling effects, impacts. I can't actually see my, they're too small from here. Oh yes, the scour protection. So making these more eco-friendly, attracting more wildlife. Reef building, you've heard of a lot of detail from Bose this morning. Cables mitigating the potential harmful electromagnetic fields from the cabling. This is a good example of an avoidance measure that can be taken, is doing something about the initial layout right at the planning stage. Monopiles have holes in them for corrosion purposes. We see that animals actually go in and out through these holes. Even a seal has once been found inside of a pylon. So they are attractive, apparently. So maybe that's something that we can do. And all of these things we're researching. But we are now taking the next step. So a lot of these measures have been researched, and I've heard a lot about metrics. Metrics are starting to become made available, but they're all at pilot level, so they're all very site-specific, and we are now starting to move to the wind farm, so the whole wind farm area, and also looking more at integrative design of the full wind farm and the whole turbine. So lots of these measures together, looking at how do they interact with each other. There's a lot possible. So my last slide, I've been thinking a lot about this. What can possibly be my, lessons that we've learned that I could possibly present here? Because there is so much going on. At the moment, I think a lot is possible in nature-inclusive design and taking measures to enhance biodiversity, but you must do so in keeping with the environment. So we've heard lots of suggestions. I've just got one picture here of a regression modeling study that we have done on native oysters. This is a model output, but it's just to visualize that the green shows the areas that on paper, using data from the field, would be the best place for oyster reef restoration. We know that they're happening inside wind farms in the southern part of the North Sea. Some work and some don't. But the message here is that you can't enhance biodiversity everywhere. You need to plan properly and also do your research. Lastly, we've been hearing a lot about an integrated approach. This is really the approach we're now taking more and more in the Netherlands. The upscaling of the wind farms is absolutely huge, on top of everything else that is already happening in the North Sea. And on top of that, we have climate change and population increase, and you name it. So we're now looking more and more into symbiotic inclusive design and looking at it from a base and scale perspective, so including stakeholders and at the early stage of wind farm planning, already talking to everybody. What are the objections, the challenges, and the opportunities? And we've done one study, and I thought I might throw this in here because this is the session on technology and innovation. We've just done an interview, quite an extensive interview of all parties involved in the offshore wind farm development and planning of the North Sea. So we've spoken to NGOs, industry, developers, the government, local authorities, and we've asked them, what do you think about nature-inclusive design measures? What is hampering them? What are the challenges? What are the opportunities? And when we ask the question, what is hampering the sort of the next level of rolling out these measures, almost all of them came back with non-technical issues. So it's not that we don't have the technology available, it's not that we don't understand the measures we can take, but it's more things that come down to the legislation in permitting is unclear. Small startups don't understand or cannot deal with the huge amount of legislation that they have to deal with. Lack of business case, they can't fund the pilots. And conflicting interests, and also the lack of well-proven concepts. We still need to do more research into these measures. And I'll leave it there. Thank you.
Thanks. Our next speaker is Dr. Annie Murphy, who's a senior scientist right here in Rhode Island at Inspire Environmental.
Thank you, everyone, and thanks for sticking around for the last session here. I've learned a lot over the past 24 hours, and as an ecosystem ecologist, I think of biodiversity as one thing. It's defined as the number of species in a certain area, but maybe not over the past 24 hours, but over the past couple years that I've been working in this realm, realize that biodiversity is more of an umbrella in this community, and we think of it more as maintaining the health of the ecosystem, maintaining the function of the ecosystem, and not so much the number of species. maybe that's related, and it certainly is, but that's, what we're all talking about in this room. And I hope I'm not too repetitive here in terms of what everyone else has been saying over the past day and a half or so. But I wanted to take a moment to think about and reflect about the major change in the ecosystem associated with the development of these offshore wind farms, and that's that introduction of new structure to the marine environment. And again, as an ecosystem ecologist, I think about really the flow of energy in an ecosystem and how animals and other organisms facilitate that flow of energy being carbon and nutrients. So once we introduce this new structure, there's a new habitat for animals to grow on. And this leads to differences in the flow of energy through the ecosystem and the connectivity within the ecosystem. And this happens at multiple scales. From upper trophic levels, moving that energy from one trophic, the basal trophic level, up through the food web, but also something that not everyone thinks about is the microbial processes, the biogeochemical processes that are moving carbon around. And offshore wind is going to affect all of those processes. So, for example, species distributions, we're introducing a novel structure. Benthic species will colonize that novel structure. I'll show you, hopefully my videos work. I'll show you some examples of that we've collected data on. There'll be changes in the community structure and diversity inherently, because now you have this structure that goes from the seafloor all the way up to the intertidal. That structure wasn't there before, so this epifaunal community couldn't be there before, and now it's able to grow there. These structures may have the ability to facilitate poleward expansion of species. So that's changing the species distribution, allowing some warmer species to move poleward as climate change progresses. There's also the potential that opportunistic non-indigenous species colonize these new structures. They now have the chance to grow on these structures. So that's changes in species distributions, as we're talking about net positive impacts on biodiversity, that is related. And as a result of those changes in species distributions, that changes energy distributions. So now you have this monopile that is colonized by basal trophic levels. So the lower trophic level organisms, things like blue mussels and other encrusting epifauna, they're living and surviving and changing where the energy is in that food web, really. So that's changing energy distributions. And this changes where the carbon's flowing in the system. It's directing carbon from the pelagic in the phytoplankton to that monopile, that structure, and then it's shuttling that carbon to the seafloor, as well as to upper trophic levels as grazers and predators come in and eat that new biomass. So that's an important piece to this puzzle. And so we should think about net positive impact associated with changes in this ecosystem function, not just the biodiversity. Let's see if this works. Yes. So I was going to pass around some popcorn, but as you're looking at this footage, so this is footage from CVOW. This is one of the 2 monopiles off the coast of Virginia. This is about 3-4 months after construction. And what you can see, this is the anode cage. So depth is 12.5 meters here in water depth. And you can see there, you might not be able to see very well, but there's there's animals encrusting that new structure in the form of small bryozoa, some barnacles. You also saw some fish. This is 2 years later in the same spot. So this is, well, 10.5 meters deep. A lot of fish colonizing there, a lot of blue mussels, and the amount and the diversity has substantially increased. So not just the basal-trophic level, but also the higher trophic levels. Those fish are using that structure as refuge and also for foraging. Let's see, so then this is the part of the monopile, at the base of the monopile. This is, again, 3-4 months after construction, 2020. Hopefully you don't get seasick here, but we're looking at the base and the scour protection around the base of that structure. We're moving backwards. The ROV is moving backwards. So this structure at the base of the monopile is also colonized by a thin layer of biofilm and bryozoa. There's a lot of fish moving around, even though there's not a ton of food there yet. I mean, there's food, but they're attracted to the structure. And then 2 years later, and as you're looking at this, think about, okay, species have definitely been redistributed here, and the energy has to be changing. So now we have all of these fish. Now we turned around and we're going to move forward along the scour protection layer. You see at the base, not as much blue mussels. So the filter feeders have sort of dropped off. There's not as much advective flow there, not as much food availability to them, perhaps. There's also more benthic grazers and predators, or sea stars and sea urchins. So thinking about, that really gives you a picture about what's happening at a local scale on each one of these monopiles. So how do we scale that up? And also, what else do I have to say? Oh yeah, right. So how does that influence the flow of carbon from the pelagic to the monopile down to the sea floor? So all of those organisms growing on that monopile are feeding on phytoplankton, most of them, a lot of them, and a lot of that material is getting shuttled through biodeposition, general falling of detritus to the seafloor surrounding the monopiles itself. So this is influencing the function of the soft sediments around the monopiles as well. So this is a plan view image on the left from 2020 at one of the locations not too far from the base of right after the scour protection drops off. So there was not a ton of organic matter there to begin with. And then 2 years later, that community has completely changed. We see a really thick layer and thick bed of polychaete worms growing in this really food-rich, soft sediment environment. And ultimately, when you deliver organic carbon to this type of soft sediment, it now has a chance to stay there because it's in an environment that the respiration of that organic matter, the conversion of organic matter to CO2 slows down because there's not much oxygen in these sediments. So that is potentially an opportunity, another potential avenue to demonstrate net positive impact is the facilitation of these new structures in delivering organic carbon to a spot where it can stay there for quite a long time. We need to measure those things, though. This is a project we did with TNC. Drew mentioned it, so I don't think I need to go into it too much. But I really wanted to harp on the fact that we need to measure it. We need to understand what do we expect is going to happen, and then develop monitoring plans to demonstrate what's happening. Not so much, well, it's important to understand what's happening as we change the system incredibly, but also to address whether we're meeting our net positive impact goals. And we talked a lot about that over the past several talks about, identifying the specific goal that you're trying to accomplish. The next step, once you establish that goal, whether it be facilitating carbon burial, you need to design a monitoring program that's hypothesis-driven. You say, I'm going to do this. If I do this, then this will happen. You need to show that through science-based monitoring. And a lot of developers are doing that. They're working towards that goal. So future work for us, we're continuing monitoring CVOW and other structures that are going to be built soon. We are using technology that is going to, optical technology that's going to show how much biomass is actually there. So taking stereo imagery and creating 3D models of these structures to understand how much biomass is growing on this, how much of it is mussels. That can lead into ecosystem models, and that can, ultimately determine or predict how much carbon is flowing through that new ecosystem. All right, I think my time is up.
Yes. Thank you very much. Thanks, Annie. Our next speaker is Heather Kinney, who is coastal restoration scientist with the Nature Conservancy right here in Rhode Island. The floor is yours, Heather. Thank you.
Hi, everybody. Like Chris said, my name is Heather Kinney, and I work at the Nature Conservancy here in Rhode Island as the coastal restoration scientist. My role here is to help carry out a range of coastal restoration and enhancement projects, including improving fish passage, stormwater management, shoreline stabilization, and installing fish habitat enhancement projects like oyster restoration and artificial reefs. And today I'm here to talk about the very first artificial reef installation in Rhode Island using reef balls, not to be confused with Rhode Island's first ever artificial reef that Remco already shared earlier in one of his presentation slides, the Jamestown Bridge. So before I get into it, I just want to orient everyone to where this is. So on the left is a map of Rhode Island, and the boxed out area is known as the Providence River Estuary. It's zoomed in on the right, and as many of you may know, and as we have talked about a bit over the last couple days, estuaries are critically important areas for a number of reasons. They're known as nurseries of the sea because so many different organisms use them for spawning and early life stages. They help combat impacts of climate change by providing natural infrastructure against flooding and erosion. Marshes and seagrass beds help capture carbon, and estuaries support the coastal economy through shipping, commercial fishing, and tourism, etc. There's a party going on here now. But because coastal areas are also the most densely populated, protecting and enhancing the benefits of these particular ecosystems is critically important. Not more important than other places, but critically important. And as other folks have mentioned, some of the best restoration that we can do might not necessarily be in the location where damages occur, or which was brought up today and yesterday, creating an NPI for offshore wind may not be primarily be on site. It may be off site or an out of kind effort. But the Nature Conservancy in Rhode Island has been working closely with the State Department of Environmental Management, Division of Marine Fisheries, on studying the Providence River Estuary to collect baseline data and identify fish habitat enhancement opportunities. So this partnership ultimately led to the installation of the first artificial reef with reef balls in Rhode Island. This reef was installed in 2019 at Sabin Point, right where the yellow star is on the map here. And I think everyone has, is this? And this is one? There we go. So this is a pilot project funded by the US Fish and Wildlife Service, Sportfish Restoration Program, TNC, and the Rhode Island Saltwater Anglers Association. It's made up of 64 cement reef balls from Reef Innovations placed in 4 separate arrays about 120 feet from a fishing pier, which you can see in the lower right-hand corner. This is a small area, a 200 by 200 square foot leased out area that this is in. But the main objective of this study is to determine how artificial reefs can be used as a fisheries resource and fish habitat enhancement tool in estuaries like this one, and also as a way to support the local community through improved recreational fishing opportunities. So this site was monitored pre and post-construction and continues to be monitored with annual dive surveys and monthly fish trap and eel pot surveys. The dive surveys used a modified kelp ecosystem ecology network approach. And so this is a standardized sampling approach or protocol that's used across the world. And because it's standardized, it can be used to help compare a variety of different ecosystems against each other, not saying one is better than the other, but just as a useful comparison of other things like eelgrass, oyster reefs, and et cetera, and artificial reefs. So far we've seen an increase in fish biomass and colonization by shellfish, and we've got similar photos. You can see the blue mussels there on the right. So we can start to make some comparisons between different habitats and restoration techniques to help support different needs. And so again, the ultimate goals here are to enhance fish habitat by providing structure for fish in a habitat that currently was not present before. And we already know why we are doing this. We've talked about this in previous panels. But in addition to the actual structures, the resulting epifaunal colonization, the algae that have attached, the barnacles, the bivalves, and other colonizing organisms on this artificial reef will provide food and enhanced habitat for fish species. The increase in fish abundance created by the reef systems could also help improve the recreational fishing experience at the park's pier. And finally, this array is now here to help advance research and impacts of artificial reefs in Rhode Island waters and provide the first artificial reef ball research station in Narragansett Bay, which can serve as a model for future artificial reef initiatives. So I mentioned, we've mentioned challenges to monitoring this earlier and quantifying what success looks like, and the level of positive impact from different types of projects is one of them. And restoration at scale is very important, but installing pilot studies like this one can help us understand how to do this better and about being able to capture all the ways that these, in this one case, artificial reef installations can impact the ecosystem and other co-benefits it could have, like wave attenuation for shoreline stabilization, for example, and fishing opportunities for folks around this area. So I have to admit that coming and speaking at an offshore wind symposium as a coastal scientist was intimidating to me, but reflecting on everything that I've learned and all the conversations that I've had over the last couple of days, it's really reinforced my understanding that all of our work is very much connected. And I knew there were connections through, ports and cables to offshore wind and the connections between migratory fish species, and just as a whole, all of the system is connected, but also that we are connected through all of our challenges, especially when it comes to quantifying these benefits and impacts. But through that, we're also connected by all of our solutions. So I'm really grateful to be here and to be part of these conversations and some of these solutions with all of you. So thank you.
Okay, great. Our next speaker is Jamie Lescinski, who works for Boskalis also, and she is the head of business. She's the business development director for US Renewables and also leads the Providence office. Jamie, thank you very much.
All right. Hi, everybody. So earlier you heard from Remco, my colleague, who, showed the bridge blowing up, creating an artificial reef here. I'm happy to report that Boskalis has some other ways that we've worked on artificial reefs around the world, amongst other nature-inclusive type designs. And what I'm going to show you in this presentation is it's kind of food for thought. So like what we've gone on a journey on for like the last day and a half is basically like looking at different temporal and physical scales of how to sort this issue out and how to make the best of it going forward. And also, as Sharon pointed out, the grass is not always greener on the other side. It's not all figured out anywhere. And also, basically, what Annie showed, you can zoom in, and that actually is incredibly important to understand in your big picture as well. And then basically what Heather showed, I'm going to show a component of that as well, is that you just need to get it done. So you need to put stuff in the water, you need to monitor it. And so what I want to show you from how we work in this space, we're contractors, like we're maritime contractors, we go build things. We dredge things, we build things, we sink things all over the world in 90 countries. We have 700 vessels to do that. We work basically for every developer that was on the previous panel across five continents right now, and we work on 6 continents. And this nature inclusive design component, this aspect of trying to increase biodiversity, have a positive, net positive social impact, these are things that, from our experience in the worlds that we work in, because we work in offshore wind, but we also work in offshore gas, oil and gas. We work in island development. We work in port construction. We work in salvage, in all these different maritime fields. And what we see is that the maturation of these maritime industries, the further you get along in each one of these industries, the more fluid it becomes, the more regimented and structured it becomes, but also the better ability to work on these bigger regional and bigger picture scales. It becomes a lot easier. So like what we see in our dredging industry, for example, globally, is that this whole picture of how do you incorporate biodiversity and positive social impact on a project scale, but also on a regional scale, it's just what we do on every single project. It's not even a question. It's just we know we're gonna have to compete on that. We have to compete on it in every continent that we work on. It's no longer a question. It's been there, it's expected, we do that. But in these newer industries, you got some bigger issues to deal with first before you also sort that out, is what we see. And it's not to say that it's not important, but we find other aspects like labor agreements tend to take the forefront. And then this bigger picture of like good for climate, good for community, good for the environment comes along with that maturation. And so what I want to give you a flavor for within this presentation is the tools that we use to do our work, because we're at sea all the time. So we're all talking about how to build things at sea, how to have restoration activities. One of the most expensive aspects of those activities are the maritime pieces of equipment and tools that you use to do it. To mobilize them, to run them, and demobilize them is a huge amount of money. We know, that's our business. And if they're already out there, use them. You know, there's a lot of downtime. Let's be smart about this. Like, let's use them. So I'm going to show you a video. It's going to take 2 minutes, so you can kind of sit back and relax. And the point is not to say, oh, wow, Boskalis has a lot of equipment. No, the point is to say that we are amongst a community that has a lot of equipment. We use every single piece of equipment that you're going to see in this video in the US for offshore wind. So, but I have to find the video. Hold on a second. Nope. Nope. I think I'm there. Okay. All right. And this life cycle is super important. Like, can't iterate it enough. We need to look at it on the entire life cycle of a project. If you want to have success, you want to know what works and what doesn't, and it's okay for something not to work. We've done that too. It's all good. That's how you learn. Monitor and look at it on a life cycle. So you're looking at substations, offshore substations. You're looking at foundations. There's all different types of foundations. Lots of folks are talking about monopiles. In the US, we also install jackets, floating wind farms. Every floating wind farm in the world, we've been involved in some way, shape, or form. You're looking at installation frames. That's not even the base, that's just a frame to install a foundation with. You're looking at basically the structures to put in for the foundation, as well as the adjoining structures around and to support the foundation upon which the turbine is attached. You're also looking at, this is the transition piece that goes on top. These are jackets, so these are very common in Asia. The US is starting to look at them. There's some for the offshore substations. These are the substations themselves. So there's been talk today about the HVDC stations and HVAC stations. So where do you transform your power offshore? That's them. Rockworks, we install scour protection everywhere. Cable protection systems. Rock is an unbelievable nature development resource. Everything loves to attach to it if you use good rock and you place it in the right way. So this is all here and it's coming here. And so these things can all be used to also not just construct the key infrastructure that you're going to see, but also to install nature inclusive elements, habitat restoration elements. It's just about being a bit more forward thinking and being prepared for it so you can contract it at the same time. Okay. Nope. Nope. There we go. Okay. Sustainability. So Boskalis, like, how do we handle this? And again, we're not unique in this, but the way we try to put it together and piece it together and also track it, we use the SDGs. And so we identified basically a few that really make sense for us and for our business globally. And then nope, I still don't have this figured out. Okay. We then basically try to bridge it with our backbone of how do we like to work. So we work safely. We work where we basically put our people, they're number one, they're first. And then we try to distinguish ourselves from our competitors and ultimately contribute to sustainable growth. We also assess this on a project by project level. So there's lots of talk about, do you look at it regionally? Do you look at it for an individual lease area? Do you look at your portfolio? So when we look at it for ourselves, we look at it in this way for our portfolio. We assess it against each SDG over the course of a year by looking at every single project. And then what I'm showing you on the bottom, these are 3 of our projects where we basically have nature inclusive design, habitat restoration elements. And the reason why I highlight these 3, Remco spoke earlier about Markervaden, that's the one in the middle. These ones, for me, are really great examples of why they worked, is that it's not us doing it, it's not us and our employer doing it, it's actually a collaboration where basically there's partners that have intrinsic value to the long-term monitoring, learning, and publication of what's happening here. We're ephemeral. We come in, we build it, we leave. We want to know what's happening, but we have no rights actually to that area after we're gone. But we have the mandate and the responsibility to build it while we're there. So as long as we partner up with organizations that are there for the long haul and have the right to monitor, they want to publish on it, and they have the right to do it, universities, great for that, and they want to learn and share it, it's awesome. That's where we have the best successes. So that's the Monaco Reef Pilot in the left. There's the Markervaden, so that's a whole habitat was created as an artificial bird island, basically. And on the right, it's Indonesia. It's using coastal protection solutions. And these things are all either offset systems, contribution systems, or just integrated into our projects. And I'm almost done. So that's this. You need to work together. And then the last piece is that basically, don't stress. It's going to come as the market matures. Everybody will work together and find their way, and it will get better and better and better. Basically, there's opportunities to use the equipment that's there. Let's do it, and let's get stuff in the water to learn from it. And also, I totally agree from the sentiment of the last day and a half. We need to ramp up nature inclusive design here for the applications in the States, and basically look at the life cycle monitoring, because then we'll really know what's going on. Thanks.
Thank you, Jamie. Now I'd like to introduce Adam Baske. Adam's the Vice President of Coastal Markets and Restoration at Running Tide in Portland, Maine. Welcome, Adam.
Hi, everyone. It's great to be here, and thanks to everyone for a great couple of days. I've learned so much. I've been very inspired, and it's just great to be in a room full of solutions-oriented people, I think, here tackling something we are really passionate about. So let me get the clicker here. Yeah, so a little bit about running tide and the role emerging technologies can play in this space, not just in the development of nature-inclusive design, which we've heard quite a bit about, but also in that quantification layer that I think is, everybody's hungry for. How do we quantify NBI? How do we define it? How do we create metrics? And I think there's a role for some of the technologies we're developing in this space. Well, where's this?
You get to point it to, and then the bottom one.
Oh, they're giving up. Technology's giving up. Let's add it. All right. Great. Sorry about that. Okay, so a little company history. I don't have the fancy obligatory slide like all the developers. We're not quite mature enough yet for that, but Running Tide started in 2017 in Portland, Maine, and we were initially focused on automating oyster aquaculture, of all things, bringing automation, bringing robotics to that, machine vision to count oysters, machinery to automatically clean it, put it back in the water in a plastic-free, custom-made environment that we were building there. And we still do that. But in 2020, we expanded our remit and started to get more involved in offshore carbon removal, and importantly, in developing the technology and the tools to quantify and verify carbon removal in the open ocean. So that's where a lot of our effort has been focused in the last couple of years. Our expertise spans across kind of the development of those ocean-based technologies and quantification systems, more economical sensors, biological enhancements. So in addition to shellfish, we also now have expertise in growing a range of macroalgae and applying them to different substrates, whether they be on offshore buoys or nearshore environments, red, green, brown algae. And then I think, importantly, it's the creation of the data products that when you combine the verification systems and those biological enhancements or those nature-inclusive design elements, how do you combine those things to turn it into usable data for the market? And the market being the users of, is it carbon removal? Are we talking biodiversity? Are we talking nutrients? In general, we kind of think of this under the umbrella category of ocean health. And I like some of the comments I've heard before that, biodiversity may be the term we're using here, but I think what we're actually meaning is much broader than that, is what the enabling environment that allows ecosystems to thrive, not just the specific numbers of species and taxa. Oh, sorry. So yeah, our approach is really 3 steps here: diagnose, deploy, quantify. Diagnose, so that's where our sensors come in. What's happening in the marine environment? What's the issue? This is where we can collect that baseline information and work with partners on whatever those best practices are. And it's not just from sensors. We're also developing in-house environmental DNA techniques. It's an emerging field. We've heard a little bit about that throughout the presentations in the last couple of days. But that field has a long way to go, and we fortunately have a team of genetics folks in St. Louis, of all places, where we're developing environmental DNA techniques. Deploy, when we say deploy, it's more designing these interventions, nature-inclusive design, whether it's shellfish, whether it's macroalgae, and finding the operational partners to do it. We don't want to own 700 boats all around the world. We want Boskalis to own 700 boats all around the world, but put our quantification and our interventions on those boats while they're building out the projects. And then last, and I think most importantly, is quantification. We have these things in the water. What can we quantify reliably? How do we work with scientists and other verification bodies to bring meaningful, auditable, robust data products to the market from those interventions? And so here's just a quick list of some of the species we work on right now. Oysters, surf clams, Atlantic scallops, a range of macroalgae species, and then this category of beneficial sediments. I think we heard from Bose that limestone was a great thing to put out in the water for growing oysters on, but substrates like limestone and other metal silicates have beneficial impacts on a range of anything that's shell forming, forams in the sediments, other shellfish species. They buffer against ocean acidification, which is a major problem around the world. So deploying those in coastal environments or even offshore environments and offshore wind areas could have quantifiable ecosystem benefits. And this is just a diagram of, what could these applications look like on a wind lease? You can have shellfish throughout the lease. Again, these areas are going to be too deep for oysters, but not for surf clams, and not for sea scallops, species that often local fisheries are quite interested in. They don't have to be deployed on the lease. You might want to do it closer to shore in a native bed, but the idea is you can enhance these populations and bring fishermen in as partners in the recovery of these shell fisheries and enhance their livelihoods and improve their catch per unit effort. If you can grow them at scale and deploy them, get them to a size where they'll survive out in the wild and avoid predation. That's one thing we're working on right now. We have a grant from NOAA to explore growing scallops at scale in our coastal aquaculture technology, and we're also doing that with surf clams. And then there's a range of other things we can do on the scour pad, on the cable runs, attaching kelp in a concept called green gravel, which is kind of growing notoriety around the world, and so you can kind of kickstart the establishment or reestablishment of kelp forests or other macroalgae. And importantly, we have the censoring and the monitoring. I mean, all of this has to happen. You need to get that in the water before any of these interventions to actually be able to quantify any kind of change or impact in an area. And diagrams are nice, but just thought I'd show pictures of, we actually do this stuff. When people hear startups, sometimes they just think you build apps. But we build things, and we grow animals. This on the bottom right is our automated shellfish growing system that we have in operation in Casco Bay, Maine. The top right is surf clams that we can grow in high density. We've built mobile kelp hatcheries that you can put in shipping containers and ship them anywhere around the world to start getting immediate results and start working with the local species and start testing out concepts like green gravel. And again, it's all about learning, iterating, getting it in the water, quantifying, improving, working with partners. And so, again, back to the quantification, a lot of the technology we're building is buoy-based. I already talked about the genetics capabilities and environmental DNA, but it's also about how can we use tools like machine vision to help quantify some of these impacts, whether it's on a scour pad and looking at fish and bivalve communities and quantifying carbon, or offshore, looking at the amount of kelp biomass grown and using machine vision to calculate the amount of carbon that's being sequestered, nutrients that are being uptaken into the tissue and assimilated. So we have machine vision, sensor buoys, grow-up platforms, eDNA, but at the end of the day, it allows you to have meaningful data outputs. And again, it's not about us just saying, believe us, we did it. We need to work with partners. We need to work with universities. We need to work with third-party auditors to verify and make this stuff transparent. And here's just a look at our kind of data flow for our, basically any system. This is kind of a shortcut look at our carbon products, but there's the data collection phase from the in situ sensors, water samples, et cetera, comes in. You have the data analysis stage, goes through the verification platform, and at the end, you have the quantified outcomes, those data products. And I like to say that, we are more active in the carbon world, but carbon is just the tip of the iceberg in terms of the ecosystem services that the ocean delivers, not just to the environment, but to humans, to society. The nutrient cycling, habitat, biodiversity, supporting wild fisheries and coastal communities. And I think the more we can work together and find define metrics and quantification tools for the impacts that some of these interventions are having, I'm pretty confident there are going to be markets for these products, not just for net positive impact, but beyond. So that's all I have. Thank you very much.
Excellent. You guys are doing a great job on timeliness. Our last speaker of the panel, Dr. Emily Shumchenia, is the director of the Regional Wildlife Science Collaborative, which is a mouthful. She has been referred to many, many times because of the great work that she's doing. So let's hear about it.
All right, thank you. Don't worry, shortest slide deck I've ever brought to a meeting. Let's see. I want to figure this out before I start talking, so. How does this work? Next. The giant button that says next. Okay. Okay, hi everyone. I'm Emily. RWSE has been mentioned several times. I'm really thankful for that. We've permeated consciousness. I'm going to talk just a little bit about what RWSE is, quick RWSE 101, and then why we can potentially be helpful here in this topic. So really important to note that the federal agencies, the Atlantic Coast states, all of the Atlantic Coast developers, and several ENGOs at both national and local scales co-created RWSE. They asked for this entity to exist. They created it so that they could coordinate with each other and with the research community. And we use research community very broadly. It's not just academics. It's the scientific experts within the consulting companies, within other private entities, and embedded in the agencies as well. The breadth of expertise that comes to the RWSE table is immense. As we all know, there's 27 active leases on the Atlantic coast right now, right? The federal agencies are funding and requiring research. The states are funding and requiring research. The developers are doing their own research. And so to help keep track of it all, they established RWSE. They want assistance with tracking who's doing what, who's funding what research, what data are being collected, and can we all collect it in standardized ways so that 2, 5, 10, 20, 30 years down the line, we can compile it all, look at it together, and conclude something about what we all just did, right? So it's a really practical intent. I, in my capacity as director, also work very closely with the 2 regional ocean partnerships on the Atlantic coast. We call them NROC and MARCO. It stands for Northeast and Mid-Atlantic Regional Councils on the Ocean, more or less. These are long-standing organizations. They've been in existence for almost 20 years. They do a lot of the same coordination and convening in these realms with the federal and state agencies, various marine industries, scientists. You may recognize the logos for the regional ocean data portals. They have both been established by these regional ocean partnerships to create a common framework where everyone can look at the same data sets related to ocean and coastal management and decision making. So we're applying some of those same concepts to RWSE, and we're leveraging these familiar tools, familiar faces that convene NROC and MARCO for the last couple decades. Importantly, collaborations, existing collaborations and growing collaborations with the federal IUS program, the Ocean Observing Program. So the Northeast and Mid-Atlantic regional coastal ocean observing systems. We've also, through RWSE, involved SOCORA. These are the groups, SOCORA, this is the southeast version of the IUSs. These are the groups that are actively out there measuring oceanographic and meteorological parameters. Many of the developers actually contribute their Met Ocean and other oceanographic buoy data to those platforms. So they're important data managers and communicators as well that we've partnered with under RWSE and the regional ocean partnerships. So what does RWSE actually do? So we have an annual work plan that is approved by a steering committee. There's equal representation from the 4 sectors on the steering committee, and they rotate their membership, although we've had a great same steering committee for the past 2 years as we've gotten up and running. There's actually 4 steering committee members in the room: Stephanie, Carl, Jen, Kate. So from each sector too, that's insane. And former steering committee member, Paul. So all these folks, essentially, I work for you guys. So you guys tell me what to do. You write up the annual work plan with me, and we decide how we're going to tackle these issues. And so for the last couple of years, what we've been doing is developing an integrated science plan for wildlife habitat and offshore wind energy that will articulate, who's measuring what? Are we measuring the same thing? What methods should we be using to measure those things? Where are we putting the data? Can we put the data in the same format and in the same place? And importantly, are we asking the same questions? And if we have common questions we want to answer together, can we align funding to answer them collectively, collaboratively, instead of piecemeal, one by one? So that's one major piece of work that we're doing. The draft science plan will be released at the end of June. We have 6 wonderful expert subcommittees that include all of the sectors, as well as research community members and other experts that have been writing this science plan with us. Next week just happens to be like RWSE subcommittee week. You pick a day of the week and join a subcommittee meeting. They're all meeting next week. And they're great, really interesting meetings to hear about, what's on everyone's minds in terms of research priorities and how we're gonna tackle this issue, this problem of understanding change with respect to offshore wind at really large scales. So that's one goal. Later this year, and actually starting now, we're beginning to build the framework for how we actually align funds to meet our common goals. So we're building up the capacity to manage and administer a large research fund where we can actually use the science plan to start implementing some of the data collection and research that we all identify. And I think the concept of bank accounts was mentioned yesterday. Like, we just need to open a bank account and start putting money in it. That's a bank account. It's already collaboratively funded by the 4 sectors, and that's a bank account, and again, collaboratively funded. So we have some scaffolding available to start working on this MPI issue. I think it is embedded a little bit in this integrated science plan in the sense that we're looking at how do we coordinate data collection and monitoring and identify common questions. So this is my last slide. I think the thing I wanted to end on is we have some tools. You all have helped create those tools, and all you need to do is tell me to help you work on them for the next annual work plan. And I yield the remainder of my time. How did no one make a legal joke in this? Okay. Thank you.
Thank you.
What's your number one topic in the science plan?
The number one research priority? So I'll tell you on June 30th. But in the serious answer is that there are so many that we're not prioritizing them right now. We're collecting them from the research community, identifying the breadth of information that people want to know. And then this summer, each sector, so the feds, the states, the developers, and the ENGOs will get their copy of the science plan, and we're going to be asking them what their number 1 and 2, 3, 4, 5 research priorities are, overlaying those to look at what's common across the 4 sectors. And I'm hoping that at least 3 are common across all 4, we'll see. That's kind of a joke. I think there'll be more, but that's the plan.
Other questions? Come on, there's so much in there. Adam.
I'll start. We've been hearing a lot about environmental DNA. Just curious on the panel's thoughts and if that's been used for looking into biodiversity or used as a metric in the North Sea, or experience and learnings we have from using that as a tool for one way to monitor biodiversity here.
Yes, that is something that is being used in the North Sea. It's, I think it's still in its early stages, but you're asking the wrong person. The way it works with the way we do this is we have a couple of sister institutes. We've sort of divided the huge amount of work that has to go into the research that, because we also have our own North Sea program, research program. And we've sort of split the ecosystem into different categories, and we focus on the abiotic phytoplankton, zooplankton part of the ecosystem, and we have Wageningen University Marine Research, which was mentioned today by somebody. They have all the expertise on this, so I can point you to the right person, but I don't know myself.
In the US, I think it's gaining traction. There's a lot of questions about, I don't think it's there yet, right? So there's issues with how long does the DNA stay in the system, so time scales, spatial scales, and then the issue of the library. And it works well if you're targeting or you're asking or hypothesizing about a certain species that's well characterized in its genetic makeup, right? So if it has a barcode and it has a good a library. So if you're looking at one species and you're trying to target that, I think it works well. But biodiversity and understanding, translating eDNA, we still need to ground truth it, I think, with traditional data collection, which we're working towards and people are working towards. So we've proposed a couple of monitoring plans that have included eDNA, coupled with traditional collection techniques. So I think it's exciting. I think it's a cool tool that could work well.
I know we're sharing a mic here, but I can echo that. I think we're just in the very beginnings of having some conversations about it, but to Annie's point, the more serious beginnings of conversations have been more about fish passage and tracking like river herring rather than doing a biodiversity assessment for like saltwater or brackish water species. So it is a lot more simple to focus on extent of a singular species or an invasive species, for another example. So.
And if the question's like presence absence too, it works really well if that's your question, yeah.
Any other questions from the panel? Okay, I have one. We want to be, we talked about in our planning meeting being sort of forward-looking in this panel and in this meeting as a whole. So what's one thing that you think we are going to be working on in 5 years that we're not doing now? And this like eDNA might be one of those things, but we've all talked about through this meeting about the sort of maturing industry here in the US and around the world, sort of rapid deployment. What's something we're just talking about now that we're going to be working on in 5 years? I'll start with you, Sharon.
Thanks. Well, I can tell you what I hope we will be working on, and I think that's getting our data organized and sharing our data and disseminating our data, because there's a huge amount of data that's already being collected. The Dutch government does a lot of trend monitoring, so they've been doing that for decades. There's lots of that is being stored, but what we don't have is the data from the wind farm developers, because that's kept confidential. It would be really nice if we could access that and share that. And we have databases, and they're open for everybody, but it hasn't got all of the data that's available.
Agree with that. Annie?
Yeah, I think we're going to be analyzing the data that we've collected at the wind farms that have been developed and realizing, oh shoot, we should have standardized these techniques so that we can compare across. But hopefully RWSC can help us do that and not get too far along without realizing that standardization is really necessary. Yeah.
I like it. Heather?
I think kind of along the lines of what Sharon was saying, we've talked for a while, and I've heard other people talk about this in conversations from today and just before, about some type of like restoration rubric that has, all the different types of restoration that are possible, and I'm speaking just in coastal areas, but also in other areas as well, that can help that decision-making process happen and help make those metrics a little bit more tangible and easier to follow.
Thank you. Before Jamie goes, I just want to say, after we hear from the panelists, I'm going to go out to the audience, so you could be thinking of your questions. Go ahead, Jamie.
I think that what we're going to be doing in probably 5 years, even somewhat sooner that we're not doing right now, is digital twin developments. So basically every single development that's out there, every wind farm that's going to go out there, there's going to be basically a digital twin, so a 3D model of that system that's going to be used for the full life cycle analysis. And you're also going to use it for like your safety planning and your CAPEX stage and your OPEX stage, but you're also going to use it for your biodiversity and your social impact assessments, because it's going to be basically the one source of truth that everybody can look at that's in a quantitative and physical state. It just happens to be in a digital physical state. And I think that's going to be leveraged a whole lot more, like Deltares does a ton with this already. And it's such a collaborative means of working. And it's, yeah, I think that's really where it's at in about 5 years' time.
Wow, okay. Adam?
I'd like to think that there'll be much more effort on having more cost-effective, autonomous data collection systems. Less need for expensive and dangerous divers in the water, expensive equipment, ROVs, the development of systems that can live out on the leases, be independently powered, be scientifically robust, and give us that real-time information in a growing number of parameters that we're all interested in, and delivering it in a standardized way.
Emily?
Yeah, I would
5-year
agree.
work plan, tell us what's on it.
I would agree. I was going to say something similar, just informed by all the conversations we've had with the experts so far. Automated and real-time data collection at the scale that development is proceeding. We're not going to be able to send divers out everywhere, or even ships out everywhere, or even airplanes out everywhere. There's going to be, drones dropping stuff off and, sending equipment back and forth from land. So I think the automation of data collection is definitely huge. I also, I meant to mention, and I want to take the opportunity to mention about data specifically. We are working on data standardization and data management plans as part of the science plan, but we also have on our website a database of just the current projects that are being conducted out there by all of the different funding entities. And I think there may be some duplication in there. We're working on, tightening it up for better presentations. What you'll see is kind of a basic Excel database, but there's over 130, 140 projects on there right now. So it's not the data, but it tells you who's collecting what and where they're collecting it and why and who's funding it. And that's just a good starting point that we hope to see built out and maybe be part of this data management landscape that we hope will be much more mature in 5 years.
Hi, this question is, I think, in part for Emily, but also anybody else that may have some information that could be relevant. In this database you mentioned with the different types of projects, are they mostly research and monitoring type of projects, or are there examples of restoration projects, different types of restoration projects in a marine and estuarine environment? Is that something, we'd be really interested in? We're trying to develop, a database that can help inform us for future planning for restoration projects and in determining, how much you should be charging for mitigation credits, or to get particular types of, even if you're going beyond no net loss, to get particular types of ecological lift.
Yeah, that's a good question. Right now, the database on the RWSE website is limited to just those projects that are being done to monitor or assess or create some kind of baseline information about wildlife, the environment with respect to offshore wind. However, the Northeast Regional Ocean Council, and this is where kind of like worlds collide. So the Northeast Regional Ocean Council has for a number of years collected information related to restoration projects and coastal data sets with the exact intent that you just described, with local Army Corps. I see that Michelle's sitting next to you. The local Army Corps staff. And so I'm not entirely sure, actually. I think that lost steam over the last couple of years, but there might be some funding and interest in bringing that back up to the forefront. And it's an interesting collision, like I said, of issues here, that I think those two databases are potentially related or could be related down the road because of the issues that we're talking about here today. So I'm happy to chat more with you about that.
Thanks. Atma.
This one's for Annie. Great photos of all the foundations. That was really fantastic. You mentioned shifting a resource from pelagic to benthic, and I'm just wondering, is it a zero-sum game, or by those resources coming out and going down to, to the benthos, that it creates a niche again for phytoplankton and other bases of the food chain to kind of come back faster and be again more positive than again net zero sum?
Yeah, it's a really great question. It's like you're an ecologist. I think you are. I think we don't know. We don't know what the effect of drawing that phytoplankton away from the pelagic ecosystem is how that's gonna change. I'm not a phytoplankton person, so I don't know what limits them. I know it's more physical, so stratification, they'll bloom, and not so much grazing down. So yeah, it's a great question. Can't answer it.
Carl?
Thank you. Annie, I'm going to pick up on where you said we might be 5 years from now. And for folks who don't know, Inspire Environmental, because of your great work, is kind of been a go-to, and you're doing fishery and benthic monitoring plans for multiple different projects. And others that do that are other consulting firms and academics. And we have this conversation at RWSC with the developers in the states. But from your perspective, how do we take that where we're going to be in 5 years and turn that into where we're going to be in 6 months and accelerate that dialogue so that we're not in that space 5 years?
Yeah. Yeah, I think right now, the developers are coming to us saying, can you design a benthic monitoring plan or a fisheries monitoring plan? We bring together experts, we do the benthic monitoring plan, we think about, and there's no guidance, right? No regulatory guidance on what you're supposed to be monitoring aside from monitoring ecologically meaningful change. That's all we have to go by. So as scientists, we think about, okay, what's going to change? What's going to change that's ecologically meaningful, and how do we design something to monitor that? And I've seen other monitoring plans that don't necessarily get at that. So it does make me a little anxious about some developers are going above and beyond to design really state of the science, like very complex monitoring plans. Maybe that's too much. Maybe and what's the balance? And I do think the RWSC can accelerate that communication and that goal of figuring out how should we be monitoring this change. What's the most effective and efficient way? And it's not. We don't necessarily need to do research that's looking at mechanisms and looking at, it's more understanding, what are the negative impacts? We don't need to, and yeah, what's the most efficient way of monitoring for change? And then ultimately, what happens when we find something that we weren't expecting? So I don't know what the pathway is for that. But I do think that the RWSA is a space for that communication to occur, but I haven't seen that happening yet. But maybe in the next 6 months, we can get that going.
It's right around the corner.
Can I just weigh in on that
Please.
quickly? So at the Habitat and Ecosystem Subcommittee meeting on Thursday this week, we'll be looking at a comparison of each of the developers' benthic habitat monitoring plans, roughly. And it's not meant to criticize, but it's just meant to compare and see who's measuring what and are there commonalities among them. And so, very timely.
I should probably attend that one.
Yeah. Okay, panel, get ready. Mel has the next question.
This is the science nerd in me coming out, actually. I think, Annie, you mentioned briefly modeling, and the work you talked about really gets us in the realm of biogeochemical modeling, dynamic modeling. But I think you're probably the only person I've heard really talk about that. And I'm just wondering to what extent any of the panel think that you're going to use these large-scale models that are spatial, that can help you put climate change in and factor that into what's coming, and because change isn't going to be just about what's happening with the turbines. It's also going to be about how the whole water column changes. So is modeling part of the planning that you collectively or individually have?
It has to be, yeah. We're getting baselines, and no, I don't think anybody's assuming these are static states. This is a changing ocean, and it's part of the reason we're all here and trying to build offshore wind in the first place is how can we slow this down and maybe even reverse it. But modeling is a huge aspect of this on the regional scale, on the global scale, and I know on our team we have a number of modelers looking at how our interventions in the open ocean are going to be impacted by modeling and informed by modeling. Just as I think that as we're moving forward, modeling has to be a big part of the types of interventions and improvements, nature inclusive design interventions we're making in the offshore space.
Yeah, and we're involved in quite a few integrated research projects where we're using models, and one of them that springs to mind is Future Maris. It's a European Horizon Framework Program project that we're doing on the North Sea with probably all the countries around the North Sea, and is one of the few research projects I know of where they're looking at the different transitions in the North Sea. So one of the big transitions, not only offshore wind that we're looking at, but we're also looking at food production at sea, and looking at the scenarios for food production together with the different IPCC future scenarios. So, I don't know, modeling 50 years ahead to see if these things can be done together and what effects these will have on the ecology of the North Sea. And I think we're also benchmarking a lot of the different models because every country has their own model. And the North Sea doesn't just stop flowing at the country's borders. So, we need to connect these models. I don't think we're at that stage yet. But there's definitely a lot of effort now being put into sharing our models, sharing our research on that.
I think what's slowing down the modelers is we're taking these monitoring plans as project by project, which is not the best way to do it, obviously, but that's how it's set up here. We need to think about it as a regional change, and it gets back at what happens when you draw phytoplankton, what happens to the rest of the phytoplankton community. So that's where ecosystem models come in, and they're not really happening yet because of the lack of coordination across developers.
Andy.
Thanks. Just a statement and one question, and I want to respond to Annie Murphy. I agree with you on the need to standardize our monitoring, and I also wanted to point out there is some bright light in that direction from the U.S. government perspective. We released, when I say we, the BOEM and NOAA Fisheries, where I work, we released a technical memorandum committing our agencies to establish regional monitoring standards and data accessibility moving forward for projects in the Northeast region. It's going to take a little bit of time to stand that effort up and what it looks like, and we look forward to working with partners in the region to do that. The one, so that was to let you know that it's a problem and we need to fix it for sure. The question I have for the group, there was a lot of discussion about benthic habitat and understanding benthic habitat, particularly in the light of net positive impact. The other side of that ledger is pelagic interactions and pelagic impacts, and I'm curious what members of the panel might have any thoughts or experience, particularly Deltares, et cetera, and others on the uncertainty of effects caused by marine and atmospheric wind wake effects, which have appear to have much larger scale impacts on the marine ecosystem in terms of the area and duration of effects and potential impacts on net primary productivity and other parts of the ecosystem?
Well, I'm very pleased with that question because this is one of the aspects that we're looking into, and I didn't have time to mention this because we had to keep it short today, but at the moment, we don't have that many monopiles in the system, in the North Sea as a system, but we're about to have thousands of them. And what we are, and we're doing modeling studies into the impacts of all of these wind farms. And what we know from other countries, and I think in Germany they've already seen this, is that if you build a certain number of turbines, you're going to have a wake effect, and that's going to have a big impact on the hydrodynamics of the North Sea. And that's what we're also seeing in our model scenarios that we're running. So we have models where we have coupled hydrodynamic ecology models. And like I said earlier, we focus on the lower trophic levels. So we do the hydrodynamics, we do the phytoplankton and zooplankton, and then we look at other institutes who do the upper trophic levels. So about the fish, I'm afraid you're going to have to talk to one of them. But what I can say is that what we can see happening with the wind farms that are going to be developed now, between now and 2030, is that we can already see de-stratification in the North Sea. And this will potentially have a very significant effect on primary production. So we can see now that the effects are that the spring bloom is going to be shifted by a month, which will have a huge impact on primary production, which will have another knock-on effect on zooplankton, so the whole rest of the food web. What it exactly means, the shift is going to be in time and also in space of the North Sea. There's going to be de-stratification in certain areas, and this is for people that don't really understand how this works. This is a really significant effect and could impact the whole of the food web of the North Sea. And this has actually got people worried about what this could mean. So we need to do more research into this because this is just the first year and a half of work that we have done. But we do know that this could potentially be very serious. And what we don't really know yet is what does this mean for the future upscaling of the other wind farms. So there's lots of questions at the moment.
Anyone else on the panel? Well, I see from the red numbers that our time has elapsed. I just want to join me in thanking the rest of the panel. Great talks. Thank you very much.